Okay, hi, I'm Mr. Kwang. Today we're going to look at the stack AADT and the concepts behind it and also how to implement it. It's not a very complicated topic, so I think we can go a bit faster for this one, right? So let's look at how we do a stack, all right? So the stack follows a very simple principle, okay? Your stack here, essentially what it does is that it only has one opening at the top, all right? So you can only put in from one end. You can only take out from one end as well. Alright, so when you want to put into a stack, right, you push into it. So this is the push. Alright, then when you want to take something out from the stack, right, you pop. And you realize that you can only take out the top one, okay, which regardless of how many plates you have, right, you can only remove the topmost plate. After you remove the topmost plate, then you can move on to take out the next plate and so on and so forth. Right? Then oops, sorry. Then the first item will always be at the bottom because that's the first thing you put in. The latest item you put in will be at the top. Alright, so this is what I mean by the last in first out property. So the item that gets put in the most recent will be the first one to come out when you pop the stack, right? So if your stack is empty, you cannot pop it. So if this whole thing, if there's nothing inside, there's nothing for you to pop, right? Okay. So how do you implement a stack in Python, right? We are essentially using a list, right? So we need to write a few accessors. We need to write a few constructors, okay, and also how to add data, how to take out data, right? So the first one is to make an empty stack. Okay, so this one will create an empty stack. So basically, you're just creating an empty list, right? Then once you've done that, right, you have two commands that are quite common, and in fact the most important for stack operations. One is a push stack item. Okay, so it appends an item, an element into the list. Okay, so when you do that, that will be when you push something in, right, that will be your latest entry, right? Okay, then when you take out one item, right, you use a pop. Okay, you pop the stack, you remove the last element in the list and so returns the remove element. So the keyword here is that you are returning, you are not deleting it, you're just taking it out from the stack and then you want to use it. Alright. Okay, then there's one more which is also quite useful for you to check what is the next item. Okay, because you don't want to use pop to check what the item is. Let's say if you are not certain what the next item is, right? If you pop it out, right, then it's gone already. So okay, so you can pick. Okay, you can pick at the stack. So that returns you the last item in the list, but does not remove it from the list. All right. So let's look at how a stack operation actually works. Right. So let's say this on the right hand side is an example of a stack. Okay. Then what I do is that first we make an empty stack. Okay. So this stack now is called S. Okay. So this is stack S. All right. Okay. So then the next first command we try to do pop S. Okay. But right now the stack is empty, so there's nothing for you to pop. All right. Yep. So empty stack, nothing to pop. All right. Then you push 7 into the stack. Okay, so 7 goes in. All right, then next one you push 5 in the stack. So you can see once you push 5 in, right, 5 is actually the topmost item. Okay, 7 is the first to go in, right, but then 7 is right now at the bottom. You push in 3 as well, so now you have 3 5 7, all right, from the top. Okay, then next you pop S, right, for the first item you take out, right, you'll be taking out 3 first. Okay, so once you've done that, you will return you 3, and then 3 is gone. Okay, now your stack is just 5 and 7. 5 is the highest one. Okay, you pop again, you remove 5, which is the last item. So you just pop it out, right? So you now have 7 left. Right? You can check whether the stack is empty or not. So you can do it is empty as, okay, equals to false. So this one you can see, if you think about this, right, this is just making use of your length of your list. Okay, so you can do length s. Okay, so you can try that later. All right. Okay, then sorry, hold on. Click wrongly. All right. Okay, then you can pick. Okay, pick. You don't pop it out. Okay, so if you do pick S, you will show 7. All right, because that's the last. That's the last item. Okay, the topmost item. Okay, pick is different from pop because remember pop will take it out for you to use. Pick is just you look at it. All right. So if right now if you choose to run is empty S again, right, you will still get false because 7 is still inside. You haven't popped out. Right. So that's it for stack operations. It's not too complex. Okay, but later you have a chance to code it. Okay, you basically just coding a list. Okay, so what can stack be used for, right? I'm just going to talk about two simpler applications for this first video. Then later for the second video, we talk about something a bit more complex. Okay, first thing what I can do is that we can use it to reverse a sequence. So for example, I have a sequence like this DCBA, right? If I put in the stack, right? That means I'll be putting in D first. So D will go in first, then followed by C, then followed by B, followed by A. Alright, so this will happen. So once it goes to the stack, right? It goes in, you push them in one by one from the front, push D, push C, push B, push A. Right? Oh, sorry. Oh, the other way around. Okay, I'm pushing from the back. Okay, so I can do that as well. Right? Okay. I got mixed up my lecture notes. Okay, so you push that in, and then when you pop it out, you can just push it. You can just take from the back. Okay? So you pop it out, right? Alright, you can do it this way. Okay, but another way of doing this is to pop. If you do it the other way, like what I previously thought I was doing, if you put it in, you will get something like this. You push in D first, right? Then you push in C, then you push in B, you push in A. Alright, then when you take it out, you will take out the first item, you'll take out A, then you take out B, then you take out C, you take out D. D. Right, so that will work as well lah. Okay, so this one is a bit counterintuitive because you are actually taking elements from the back, which is not the way we do it usually lah, but it's not wrong also. All right, okay, next we're going to look at one more application. This is something that you have done before, how to convert denary to binary numbers. Okay, so remember last time we learned how to last sem we learned to convert denary to binary, right? We use the we keep on dividing by 2, right? So maybe let's just take a simple number and say I take 47. Okay, so 47 is okay. So 47 I divide by 2, I will get 1 remainder. Then will become 23. Then divide by 2 again, I get 1 remainder. Then I divide again, I get 11, then 1 remainder also. Then I divide again, 1 remainder. Then I will get 2, and then this will give me 0. Is it? Oh, sorry. Yeah, 2. Then I get 1. Then I get 1 remainder. Then after that, I'm supposed to reverse this. I'm supposed to take from the bottom up, right? Okay, so we can streamline this process. Alright, so let me just, what happened to my slide? Okay, let me just clear off the screen first. Okay. Let me just clear pen markings. Alright, so let's look at what we have. Okay, so again, I'm using 47 base 10 now. Right, so I'm going to convert this. Okay, so let's see how I can do it. Alright, so okay, yeah, so again, we start with 47, then we divide by 2, we get 23, and remainder 1. Alright, then we just going to, every time we divide, right, we're just going to pop the remainder, push the remainder into a stack. Okay, so we're going to push the first 1 into the stack first, right? So 1 goes in, then again we divide by 2 again. Now 23 divided by 2 again, we get remainder 1. Okay, so we're going to push in 1 again. Alright, 11 divided by 2, I get remainder 1 as well. I'm going to push in the 1 again. Okay, right, then I divide by 2 again. Alright, now I also get, I divide by 5. 5 divided by 2, I get remainder 1. Okay, so I push in the fourth one. Then I have 2. 2 divided by 2, I get remainder 0. Okay, so I push in 0. Then the last digit over here, okay, the last digit here, over here, I'll just push it in. Okay, once I reach 1, I know I'll stop. Okay, so if I push it in, okay, so this last remainder 1 will go in as well. Okay, then once you have done that, right, you can just pop it out. Okay, so you just pop it out, then you'll get, let me check. So you just pop out one by one, you get 1 0 1 1 1 1. Alright, so let's check whether the answer is correct or not. Okay. Right. So okay, so just pop out one by one. Yep. So that tallies the answer that we have over here. Okay, so you can try this one. This is not too difficult to do. Alright. Okay, so I'm going to we can do one more first. One more example over here. Alright, so let's move on. Okay, we also can use it to check whether your parentheses or your brackets are balanced or not. Alright, so for this, okay, what do you understand by this, right? Okay, remember when you want to open a bracket, right, you have to close it within the same, how to say, you have to close a bracket first before you okay, if you open, let's say for example, you open this first bracket, okay, then you open the second bracket, right? You cannot, for example, you cannot do this. You cannot do this round bracket, then you do square bracket, then you close the round bracket first. You can't do it that way. Okay, you have to make sure that you have to, whatever you open inside, you have to close it first, right? So this is what I meant by balance. So for example, the first one, the first row here, this is balance. The second one is not balanced. If you look at this, I open the first bracket, second bracket, third. Okay, I close my third one. Okay, but now I open a fourth one. But before I settle this fourth one, right, I'm trying to close the second one. Okay, so this is not a balanced parenthesis, right? So you can basically use your stacks to check for this as well. Okay, so we just can't count. We can't say, for example, okay, this one is like one bracket, two bracket, 3, 4 as even. Okay, so each one has a pair, but you have to be in the right order as well. All right. So if you go with stack, right, if you see open bracket, you push in the stack. If you see a closed bracket, right, pop an element out, then compare whether it is a corresponding stack or not. All right. So you will see this example inside your tutorial later. Okay. So what it means is that if I see one of this, any of this, right, I will just put it into my stack. Okay. So let's say I see this. I see a open bracket. Okay. So I put it in. Okay. The next time I see a closed bracket, okay, I will pop the latest one out. Okay. Pop the latest item. So right now, let's say I see a round closing bracket, right? I will pop out this one and see whether it forms a pair with the one that I'm checking right now. Okay, if it doesn't form a pair, that means it's not a balanced parenthesis. You can just return false. All right. Okay. Okay, so I think let's stop here for now. You can pause for a while, try some questions before you go and watch the next video as well. All right.